Okay, in 6.5, we're going to continue to talk about shortcuts to show that the triangles are similar, and we have two of them we're going to use today. You can see up here the title SSS and SAS. So SSS, of course, is going to stand for side, side, side. SAS is going to stand for side, angle, side. So we'll start with side, side, side right here. I'm going to maybe highlight a couple of words in this sentence here. So if the corresponding side lengths are proportional, I know it says side lengths of two triangles, but side lengths are proportional, then the triangles are similar. So it has nothing to do with angles, simply the sides. So what that would look like in this picture, AB, side AB, if it's going to be if the side's going to be proportional, I have to make a ratio of AB to RS. And that ratio will have to equal AC to RT. And that ratio has to equal the bottom side, CB, to TS. If all three of those ratios are equal, then they're proportional. And that would allow me to then make the conclusion that the triangles are similar. So I would be able to then conclude that triangle ABC is similar to triangle RST. So that's what we're going to try to do. So we're going to look at this picture down here, below it. It gives us three triangles, but it's asking if either of the second ones are similar to the first. So we're going to look at the first, the 8, the 16, and the 12, or 8, 12, 16. We're going to see if it's proportional to either of these others. So let's check it. Let's compare it to DEF first. So 8 is the shortest side. Over here, the shortest side is 6. So if I simplify 8 to 6, I get 4 to 3. So then I'm going to check the next one. The next shortest side is 12. Over here, the next shortest side is 9. So check 12 to 9. They're both divisible by 3, giving me 4 to 3. So far, so good. And then 16 is my longest side. I'm going to compare it to the longest side there, which is 12. Divide those both by 4. I get 4 to 3. Yes, they were proportional. So I'll come back, but I know that DEF is similar to it. Now I'm going to check the other one also. So I'll go back to 8. It's the shorter side of that triangle. If I find the shortest side over here, it's 8. Well, 8 to 8, that's a 1-to-1 ratio. The next shortest side was 12, but the next shortest side over here is 10. Is that in the same ratio? No. So I can stop right there. I don't need to go any further. I know it's not similar to triangle GHJ. It's only similar to DEF. So a couple ways I guess I can answer. I have it circled. That might be sufficient. I can go ahead and write a similarity statement that triangle ABC was similar to triangle, let's see, A was between the shortest and the longest sides. So shortest and longest sides here would be D, between those. B was between the two shortest sides, I should say. So between the two shortest sides here is E. So B corresponds to E. And so lastly, it must be F, DEF. So those two are similar. And we know that because their sides were proportional, we used side, side, side. If we look at this next example, we're now going to solve for x based off of that. That tells us that they're similar. We know that, so then I know that sides are proportional. So I can find my scale factor by doing 4 to 12. Let's simplify that. They're both divisible by 4, so I get 1 to 3. So that's my scale factor. So I know all other corresponding sides, their ratios will be congruent to that. So let's check maybe this side, x minus 1. It corresponds to the 18. And so that ratio has to equal my scale factor, which is 1 to 3. Let's cross multiply. 3 gets multiplied by x minus 1. I'll have to distribute it. I'm going to run out of room. 1 gets multiplied by 18. When I distribute my 3 to the x minus 1, I get 3x minus 3 equals 18. To solve that, I would add 3 to both sides, so 3x equals 21, so x equals 7. This is a little bit of a unique problem because x shows up in two places. kind of catches me off guard a little bit. I have the x minus 1 that I just used, but there's an x plus 1 down here. It better be the same. I mean, that's really the reality of it. If it's not the same, then this problem is flawed. Since I already know what x is, I'm just going to plug it in and check. If x is 7, the parentheses here would say 7 plus 1, which is 8, and 3 times 8 is 24. So that should be 24. I'm going to check this ratio. 8 corresponds to 24. Does that equal my scale factor? Simplify, they're both divisible by 8. I get 1 to 3. Check. Yes, it does. Okay. So it's a little bit weird that they had x in there twice. Typically, that's not going to happen. Had I used the bottom sides instead of the right sides, I would have still got the same answer of 7. But it's weird that it had it both times, but it did. Okay, so there's side, side, side. Next, we have side, angle, side. And here the order matters. It's helpful, hopefully, that we did side, angle, side in last chapter with congruence. So you already know that the order is important. Here we're doing a side, angle, side, but and we did side, side, side before. The difference between last chapter side, side, side and this chapter side, side, side was before it was congruent. This time it was proportional. Last chapter the sides had to be the same. This time they just have to be proportional. In the same way, our sides here, I'm going to go out of order, but we're going to have sides that have to be proportional. And we'll have an angle. An angle is congruent, but this word including is important. That helps us know what order we're talking about. So angles have to be congruent, sides have to be proportional, but it has to be the included angle. So on this picture, ZX corresponds to PM. That's one of the sides that have to be proportional. And if I want to make the congruent angle included, I like to use the word flank. You have to flank the angle, or you have to surround the angle. You have to be on both sides of the angle. That angle X only has 2 sides that touch it. ZX is one of them, the one I just used, but the other one that touches it is this side over here, which is XY. So that has to be the other side I'm checking. And it has to correspond over here to MN. That way we're flanking or surrounding that included angle. I don't care about ZY because ZY doesn't touch the included angle. It has to be a side and then an angle and then a side in a row. I don't care about the other side. So I have to check those and I have to make sure that they're equal. We have the included angle that's congruent. Angle X was congruent to angle M. I have to check that the surrounding sides are proportional, and if they are, then I can conclude that the triangles are similar. Triangle XYZ, would be similar to triangle MNP. That's what I'd be able to conclude. So we'll have to check that. So we have a problem down here where we get to check. We have 2 triangles. None of the angles are marked congruent, but in order to use SAS, we have to have a set of congruent angles, but we do have vertical angles. So we do have a pair of angles that are congruent. So angle ACB is congruent to angle DCE. And then I need to check the surrounding sides. So this angle to the left, it's touched by the 18. So we have to check what 18 is corresponding to. Now be careful, is 18 corresponding to the 15 or is it corresponding to the 30? It was discussed a little bit in the last section. If you're not sure, here's a good way to think about it. The 2 sides that surround the C are 18 and 9. I just went with the bigger one. So if you look over here, the 2 surrounding sides are 13 and 15. 30 and 15. You have to choose the larger one there also, since I chose the large one here. So 18 corresponds to 30, not to the 15. I have to check and see if that's equal to the other one, 9 and 15. 9 would correspond to 15. I'm going to check these and see if it's true. I could put a little question mark above my equal sign at the moment if I write it this way, because I don't know if they're equal. I have to check and see if they are. So 18 over 30, I can divide them both by 6, giving me 3 over 5. And 9 and 15, I can divide them both by 3, giving me 3 over 5. Yes, they are in fact equal. So if I have a pair of angles that are congruent, and then the surrounding or the flanking sides are proportional. So the question was, tell what method you would use to show that the triangles are similar. I guess I could just use a justification over here. The angles were congruent because of the vertical angles. The corresponding sides are proportional, so I can conclude that they are similar by using SAS. That should be sufficient.